Today we're going to move to laws of exponents. Okay. One you already know, so it shouldn't be much more. All right, so the first one, and I need you to write this down, please, is called the product rule. Product means multiply, right? This means multiply. Sorry, it's the answer of a multiplication problem. So a to the fourth to a to the seventh, you already know that that equals a to the 4 plus 7th, which equals a to the 11th. And the reason being is that we can expand this. A to the 4th becomes a times a times a times a. And then a to the 7th becomes a times a times a, 4, 5, 6, 7. Right? Now notice that this is multiplication, and when we use the exponents, it's a shorter version of writing repeated multiplication. So in this case, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there's 11 a's being multiplied, but instead of writing it like this, we can write it like this, which is the shorter version. So for this one at the bottom, now let's do the coefficients with the coefficients. So 2 to the 4th, 2 and 2 to the 4th becomes 2 to the 5th. X to the 5th power and x to the 2nd power becomes x to the 7th power. And then y to the 4th power and y to the 3rd power becomes y to the 2nd. So I need you to write that in the product rule. When you're multiplying x raised to the n power times x raised to the n power, the short way of doing this is to keep the base and add the exponents. So this is what you need. Okay. All right, that should be an n. N plus m. And that's the product rule, right? This one you already knew. Let's move on to the quotient rule. Now the quotient rule is pretty interesting. Now in multiplication, we kept, when the bases were the same, we kept the base and we added the exponents. With the quotient rule, we're not going to do that. We're actually going to subtract the exponents. And this is going to give us a, 4 minus 7 equals a to the negative 3rd power. And we're going to talk about negatives tomorrow, not tomorrow, the day after. But for now, you can leave it like that. So a to the 6th and a to the 3rd, it's a, keep the base, subtract the exponents, and we get a to the 3rd power. Now, I rather work this in a fractional format so you understand this a little bit better. I think it's easier to see and show you the answer. A to the 4th, and I'm going to expand that. I'll rewrite it as a times a times a times a. And then at the bottom, same thing, I'm going to rewrite it as a being multiplied by itself 7 times. 1, 2, 3, 4, 5, 6, 7. Now, notice that I can simplify this. It becomes 1 and 1. I can simplify this. 1 and 1. A divided by a is just 1, right? A divided by a is just 1. So notice that on the numerator, what do I have left over? I have nothing left over except 1 times 1 times 1 times 1. So it's 1. Now at the bottom, I have 1 times 1 times 1 times 1 times a times a times a, so that gives me a to the 3rd power. Now, one thing you have to notice is that this and this is the exact same problem, except this is written in a fraction format. And I want you to pay really good attention to the answer. This is written like this, and this is written like this. But I want you to really remember that they mean the same thing. Let's do this one. A to the 6th divided by a to the 3rd, because the other way of writing this problem. So on top we have a times a times a times a times a times a, and at the bottom we have a times a times a. So now let's simplify. This and this can be simplified to 1. This and this can be simplified to 1. This and this can be simplified to 1. And in this case, I have a's left over in the numerator. So it's 1 times 1 times 1 times a times a times a, which is a to the 3rd power. And at the bottom is just 1 times 1 times 1. I'm going to write it like this, but we really should just write it like that. Okay. I'm going to do a couple more problems with the quotient rule. So let's say you had a to the fourth, b to the third, c to the second divided by a to the eighth, divided by b, divided by c to the fourth. What would that equal to? Well, for now, we're going to expand this. We're not going to do this all the time. So we have a times a times a, b times b times b, and c times c. At the bottom we have a, 2, 3, 4, 5, 6, 7, 8 a's, 1 b, and 4 c's. 1, 2, 3, 4. If you ask yourself now, we're going to simplify. But another way of start thinking is, I have 4 a's on the top, 8 a's at the bottom. Where are you going to have a's left over, top or bottom? We're going to have a left over here at the bottom. We're going to have 4 a's at the bottom. So we're going to have a times a times a times a. Let me show you. This and this simplifies, this and this simplifies, this and this simplifies, and this and simplifies. Notice that I have 4 a's here, which is what I have here. B's, I have 3 b's in the numerator and 1 b in the denominator. So this and this simplifies to 1. So where do I have b's left over? I have 2 b's in the numerator. Finally, what about the c's? Well, I have 2 c's in the top and 4 c's being multiplied at the bottom. So where am I going to have left over? I'm going to have 2 c's here. Because this and this simplifies, this and this simplifies, and look, 2 c's at the bottom. Now, you're not going to leave your answer like that. Better yet, you're going to write it as b squared a4 c squared. Let's do another one. 7 to the fourth, let me change colors. 7 to the fourth, a to the third, b to the second, c to the fifth. 7 to the fifth, a to the third, b to the eighth, and c to the second. Now, if you think about it, I don't want to expand this, but we have over here 4 7s being multiplied, and over here we have 5 7s multiplied. So if you think about it, where are we going to have 7s left over, top or bottom? Well, it's going to be 1 7 at the bottom. A to the third and a to the third disappears. It just becomes 1. So I don't have to worry about the a's. B to the second, b to the eighth, it's going to be b to the 6 at the bottom. C to the 5 and c to the second divided by c to the second is going to be c to the third. So my final answer is this right here. I'm going to expand this and I'll show you. So we have 7, 7, 7, 7 times a 1, 2, 1, 2, 3, 4, 5, 7, 7, 7, 7, 7, a, and a. We have 1, 2, 3, 4, 5, 6, 7, 8, and then 2 c's. Simplify. This simplifies, this simplifies, this simplifies, this simplifies. And notice I have 1 7 here. That's my 7 over here. This simplifies, this simplifies, this simplifies. And that means my a's are gone. They're all just 1. So I don't have any a's. There are no a's. Next, this simplifies to 1. And how many b's do I have? I have 3 b, 1, 2, 3, 4, 5, 6. I have 6 b's. And there you go. And lastly, this and this simplifies, this and this simplifies. And notice that I have 3 c's, c times c times c, but in the numerator, which is this guy right here. Okay, just one more. 3 to the 7th times x to the 4th, y to the 6th, z to the 10th, to the 4th over 3 to the 9th, x to the 2nd, y to the 7th, and z. So you should already know what your answer is going to be. Let's look at the 3's. I have 3 to the 7 and 3 to the 9. Where do I have more 7's, top and bottom? Well, on the bottom. So I'm going to have 3 to the 2nd here. X's, I have x to the 4th divided by x to the 2nd. So I have 4 upstairs, so I'm going to have 2 left over. Y to the 6th, y to the 7th, there's more downstairs. How many in the downstairs? In the denominator, so how many are left over? 1 left over. I'll put a 1 here. Z, I have z to the first here and z to the fourth on the numerator. So if after I simplify, I'm going to have z to the third. So this is my answer. Right? You can get here without expanding, but I'm going to expand. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, and 4 z's. 1, 2, 3, 4. Over 1, 2, 3, 4, 5, 6, 7, 8, 9. 3 nines times, right? Being multiplied. 2 x's being multiplied. 7 y's. 2, 3, 4, 5, 6, 7, and 1 z. Let's simplify. And again, 1, this and this one and this one, 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 this one and this one. So it all simplifies to 1. What do I have left over? I have 3 times 3, which is here. Next, the x's. This and this simplifies. This and this simplifies. Where do I have left over? I have 2 x's. Where? In the numerator, which is right here. The z's, sorry, the y's. This and this one and this one, 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 this one and this one. I have 1 y left over. Where is it? Right here. And finally, the z's. This one and this one simplifies, and where do I have z's left over? I have 3 in the numerator. Z times z times z, or z cubed. So my answer is x squared z cubed over 3 squared, which is 9 over times y. That's my final answer. So that's the quotient rule. Zero exponent. So anything raised to the first power equals 1. Let me tell you why. Let's get something like this. 5 to the second divided by 5 to the second. Well, 5 to the second divided by 5 to the second, remember what we said. When it's division, we keep the base, subtract the exponents. 2 minus 2. And that equals 5 to the 0, and that equals 1. Well, let me show you why. So 5 to the second power is 5 times 5 divided by 5 times 5. So I think you'll see y is equal to 1. This one simplifies to 1. This one and this one simplifies to 1. 1 times 1 is 1. 1 times 1 is 1. 1 over 1 is just 1. So it's the same problem written a different way, right? So here, but writing it as a fraction, you can see why it equals to 1. Okay, so anything raised to the 0 power equals 1. So 7.89 to the 0 power, equals 1. 1,348 to the 0 power equals 1. 2 to the 0 power equals 1. 4 over 5 to the 0 power equals 1. Okay, anything to the 0 power equals 1. And then we're not going to do this, but we're going to talk about the power rule. So that's the last rule you need to know today. So if you expand this, right, so the 4 is telling everybody inside the parentheses to multiply by themselves 4 times. So we get 4 to the third times 4 to the third times 4 to the third times 4 to the third. What is that equal to? Well, we can keep the base and add the exponents. 3 plus 3 plus 3 plus 3. And we get 4 to the 12. So this is 4 to the 12. Same thing here. So we're going to have 5 to the second power raised to the third power. 5 to the second power raised to the third power times 5 to the second power raised to the third power times 5 to the second power raised to the third power, right? So we took care of this guy. Now we got to do this the third power. So it's 5 to the second times 5 to the second times 5 to the second. 5 to the second times 5 to the second times 5 to the second. Again, 5 to the second times 5 to the second times 5 to the second. And the last one, 5 to the second, 5 to the second times 5 to the second. So we get 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. So this gives me 5 to the 24th power. But I'm pretty sure you don't want to do what I just did. So what's the trick? In the power rule, when we have, and I'll do this here, again, the trick is 4 raised to the 3 times 4, which equals 4 to the 12. The second one, here, it's 5 raised to the 2 times 3 times 4, which is 5 times 6, 5 times raised to the 2 times 3, 6 times 4 is 5 to the 24. So the power rule says multiply, when you have one exponent raised to the other exponent, you just simply multiply. So 3 to the second power raised to the third power raised to the fifth power. What do? We keep the base and we multiply the exponents. 3 to the third. Okay. So the power rule says exponent to exponent, you keep the base and multiply the exponents. Last rule that I want you to write down. Now this is the power rule but expanded. So let me do this way. So if you think about it, let me do this one. So 2a cubed to the fifth power means 2a cubed times 2a cubed times 2a cubed times 2a cubed times 2a cubed, right? So if we follow what we just learned and do the product rule, we can get 2 times 2 times 2 times 2 times 2. Remember, there's a 1 here, right? It means 2 to the fifth power. What about the a's? A's would be 3, 6, 9, 12, 15 to the 15th power. The shortcut to do this, the shortcut is for you to multiply. And let me put a 1 here so you don't forget that that's raised to the first exponent. Multiply this, and multiply this, times. Multiply, multiply. So it's 2, 1 times 5, and a, 3 times 5, which gives you 2, 1 times 5 is 5, and then 3 times 5 is 15. Let's do the other one here. The expand the rule says, well, let me put an exponent with 1. So that 4 is going to multiply every exponent. There's a 1 here. We're going to multiply times, 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 times. So it's going to be 3, 1 times 4, m, 5 times 4, p, 2 times 4, and w, 1 times 4. So we're going to get 3 to the 4th, m to the 20th power, p to the 8th, and w to the 4th. Okay, so that's the expanded rule. So if there's an exponent outside the parentheses, it multiplies every exponent inside. Okay, so let me pick another one here. 7 to the 2nd, a, b to the 4th, c to the 6th power, raised to the 8th power. So it's going to be 7, 2 times 8, 7 to 16. A, well, there's a 1 here, so 1 times 8, 8. The b, 8 times 4. And the c is going to be 6 times 8, which is 48. So that's my final answer. 7 to the 16th power, a to the 8th, times b to the 32nd, times c to the 48. Okay? And we'll talk about a negative exponent some other time. So actually, let's just do one more. Negative 8 to the second power, a to the third, b to the 4th, raised to the third power. So now here we're going to get negative 8. Then this is going to be 3 times 2 to the 6th power. A is going to be 3 times 3, it's going to be to the 9th power. And B, 3 times 4, which is going to be to the 12th power. Okay? And if you have a calculator, you can put negative 8 to the 6th power. Negative 8 times negative 8 times negative 8. When you have a number like that, we can actually raise it to the power if you have a calculator. So in this case, 8 raised to the 6th power equals, so we can actually, 262,144, a to the 9th, b12. Okay? All right, please write these down.